All right, so Presto team, events team, if the other folks are ready, they can start jumping in here and we can get them on camera. There's Eric. Hey, Eric, good to see you.
Hello, hello.
Great, and we have Dave. Hi, Dave.
Hey, how you doing?
Hey, and Tim's back. Good to see you again, Tim.
Hello.
And I think we're waiting on Girish here. So while we wait, I will introduce Eric, who will then introduce everybody else. But Eric Kavanaugh is the CEO of the Bloor Group. He's going to be moderating the panel today. So I'm going to kind of turn things over to him, and then he'll do the official introductions of everybody on the panel and get things kicked off. We do have 2 more minutes until we start. I know we're missing Girish, so we can hang out for 2 minutes until then. But Eric, I'll officially kind of hand it over to you.
All right. Thank you so much, Ollie. And thanks to all you folks tuning in. We're always excited when people want to learn. And I like to learn as well in real time on shows when we're broadcasting. So this is going to be fun. And Presto is really bringing the industry together, it seems to me, in some pretty exciting ways and enabling what you could call a next generation of information architecture. And I've been around a long time, so I recall the early days of data warehousing and centralizing everything in one location. And of course, we did that again to a certain extent with the data lake. But now we're also looking at some different architectures, and this concept of an open lake house is very interesting. But maybe as we wait for our go time, our official go time, maybe Tim, Meehan, just say a couple words about yourself and what's going on with you.
Yep. So I'm Tim Meehan. I help run the technical steering committee, and I'm a software engineer at Meta. Within Meta, I work on Presto, focusing on resource management, reliability, and fairness of resources.
Cool. And we have Girish joining us now from Uber. So Girish, tell us a little bit about yourself and what you're working on in the world of Presto.
Sure. Hey, Eric. Hey, Dave, Tim. Nice to meet all of you, and awesome to be on the same panel. So as Eric mentioned, I'm a senior engineering manager at Uber. So I'm mostly working on data analytics and a little bit of security and search these days. But Presto is my first passion, and I've been very closely involved with the community. And at Uber, we are very heavily invested in Presto. So we love Presto so much, we want to do everything with Presto. So I'll leave it there for now.
Okay, good. And last but not least, David, tell us a bit about yourself and what you're working on these days.
Yeah, I'm the CTO and co-founder at Ahana. Been working on distributed databases for a few decades now. I did some early work on distributed and federated systems at IBM, both Ullman Research and Software Group. I was the chief architect at an analytical database startup called Aster Data Systems that got acquired by Teradata in 2011, and I was the chief architect at Splunk for 4 years, sort of focusing on transitioning that architecture to the cloud. And before starting with Stephen and Dipti starting Ahana.
Yeah, that's a great background. So you've seen the history and the landscape that we've been traversing, right?
Yeah, I've been called a pioneer, but I don't quite like that terminology.
They can all you probably heard the expression. You can always tell the pioneers by the arrowheads in their backs. Have you heard that one? It's metaphorical. It's metaphorical. But yeah, listen, folks, thank you so much for your time and attention here today. Let's dive right in and talk about what's really happening out there. And Presto for the Open Data Lakehouse. I think, again, this concept of a lakehouse came along because we're trying to get the best of both worlds, right? We learned a lot in the data warehousing space, and then in the big data analytics space, we learned a lot about scale out architectures, distributed systems, different ways to be able to access the data to do your analysis. We have data science, of course, which is now really coming into its own. But what does this mean? What does an open data lakehouse architecture mean, and how is it really working out? So maybe I'll throw it over first to Tim to talk about what you're working on at Meta, and how did it come to pass?
Right, and so like I think at Meta, we probably had something that it could be called that, but without that term existing for some time. And so like it has, I think, a lot of the hallmarks of what you would expect. So the like the massive the scale it out, very scalable, cheap storage, disaggregated storage, and many of the features that we come to expect from lakehouses. And so like I feel like this was critical in making the warehouse cost efficient infrastructure. A bit sort of like a useful as a sort of like a general purpose tool to make business decisions, and kind of like as I alluded to during the TSC, useful by sort of like lots of different roles, from software engineers measuring to see if their new feature or their like their new improvement has sort of like correctly landed and has yielded the correct benefits, to all the way to like senior folks who are trying to see if the like this information sort of like the product is growing as expected. So I think like that's what we see, and so like we've sort of like spent a lot of time scaling it, and I think making it so that it's a reliable and efficient architecture.
Yeah, and it's funny, I've been in this business for a long time, over 20 years, and I remember 22 years ago, the whole storyline was BI for the masses, right? Business intelligence for the masses. We want to get the capability of doing queries and doing analysis in the hands of as many business people as possible. And gosh, 20 years later, we're an overnight success, right, with an open data lakehouse. But you really are talking about democratizing access to analytical capabilities, right? You don't want to limit this power to a handful of people in the organization. You want everyone to have a sort of culture of data in their DNA, and because that then leads them to make better decisions, to ask better questions, to move in better directions. It really is a sort of a sea change that we're seeing undergo in the world of business right now. What do you think, Tim?
I totally agree, and sort of like taking into account purpose-built, sort of like making sure that the purposes match the usage, and like privacy and security and such. I think it's exactly right, where it's like opening it up so that it can be easily ingested, and then sort of like used for used as needed to help drive business decisions is incredibly powerful. Like and sort of like making it so that more people are kind of like involved in understanding the data for themselves, and then also sort of like correcting their strategy like as they use it.
Right. Well, and you have much better conversations with people because you're not debating this number or that idea. You're really talking about the data and the analysis and sharing that perspective with other people. And to your point earlier, this can be the engineers, it could be the business people, it could be the marketers, it could be anyone. You don't want different data for everyone. You want different views of the data, but you want different views of the same data, so you're on the same page. And to me, that's the real magic of this lakehouse architecture, is that you're building an engine that can pragmatically, reliably, at a good enough speed, deliver the analysis to whoever is tapping in to get some insights, right, Tim?
That's the exact idea. I think you put it very well.
Well, let's bring in Girish from Uber to talk about what you folks are working on over there. And I mean, I don't think anyone doesn't know the innovation that Uber has brought into the world. And I have a friend who runs a taxi company, and so he knows firsthand the innovation that you guys have brought. But the fact is, times are changing, and you gave tremendous real-time visibility. That's the key. Now I can see where my driver is moving around. So tell us a bit about your journey and about how Presto and open data lakehouses have become a thing for Uber.
Yeah, I think that's a great insight and view into Uber. So at Uber, like most other companies, our journey started off with data silos, right? So basically, you would have what we used to call 5 or 6 years back a data lake, where all the data would land, and then people would just load subsets of that into various silos. So they would have their own little corner of the world, like various data warehouses or other purpose-built systems. And so people would be talking differently based on different data sets. Everybody had their own version of facts to pull out a meme from current times. And so what Presto really did at Uber and other places is it brought the ability for people to get the insights from the data lake directly, right? So you didn't have to make a local copy for a faster analytics experience.
Right.
And we saw that journey at Uber too. We had vendor-supported platforms, multiple of them. People had their own versions for their own customized use cases. But then once we were able to bring in Presto and scale it up, everybody started using Presto. And it's not just that everybody is talking about the same data, but more importantly, in the data lake, the data is the most fresh because that's where the data lands, right? And so not only is everybody using the same data, but they're using the freshest possible data to deliver what are their insights. And the real-time part that you mentioned at the end took it to the next level. So it's not just about data landing in the data lake, but providing a template for real-time insights, right? Data sitting in real-time systems like Kafka and Pinot and so forth, accessible through a common interface. So Presto really brought it all together and made this concept of a data lake into a data lakehouse or an open lakehouse because of the open standards we have at Uber.
Yeah, and you hit the nail on the head there with that one word, copy. We make a copy to make it faster, right? So what happens when you I saw a stat a while ago that said something like in the average enterprise, every piece of data is copied like 5 or 6 times. I mean, it's just crazy the number of copies. And what happens then is you get these bifurcations. You get like a tree or a branch. And now this is a different set of data. I'm updating it differently. And you're using the old piece, the version control is what we're talking about here on information. But once you open that can of worms, you can't close it again. And I think that was one of the driving forces behind Presto and behind this open data lakehouse architecture. What do you think?
Yeah, I fully agree. I think once you make a copy of anything, right, in distributed systems is the basic concept. Once you have a copy of something, you run into the consistency problem and you run into the control problem, right? So how do you keep your copies consistent so that everybody has a consistent view of the data? And how do you control the data, right? So privacy controls, like Tim mentioned, regulatory requirements, all of those things, a lot easier when you have one copy in the data lake. So yeah, I think it has made a lot of things easier from particularly the data infrastructure side for us to manage one lakehouse as opposed to all these different copies in silos.
Yeah, infrastructure as code. We're hearing a lot about that these days, and for good reason. And let's bring in Dave from Ahana to talk a little bit about your vision and where you saw this coming and why you started focusing on it. I mean, you gave us some background already working over at Splunk, trying to take them into the cloud. You're trying to take any massive on-prem engine into a cloud-native world. That's a pretty significant journey. And a lot of times, I won't mention any names here, but there are some big vendors that went to the cloud and they just took the same code base and dumped it up in the cloud. And, that may not be the best decision, but you never know. Refactoring, I think, is the ideal, but it's expensive and it takes time. But anyway, tell us a bit about yourself and where you see things going, Dave.
Yeah, so I think one of the big challenges that we're trying to solve is that, there's, for a customer, right, the decision to use a data warehouse versus, a lakehouse to support modern SQL-based business intelligence applications, right? So like you said, Girish said, the data lake's the first landing spot, where data's, lands in this modern cloud architecture in open formats such as ORC and Parquet. And so then there's sort of like this, what's been happening like with Snowflake, right? Data's further moved, transformed into a proprietary cloud warehouse format. And in order to get performance, reliability, scale, and data management features that are required of these BI business intelligence applications, right? So that comes at a cost, right? Time to first insights, freshness, introducing potential errors, governance issues, privacy issues, but most importantly, it walls off use cases, right? But if you need 10,000 reports done by Thursday, that cost might be worth it, right? But the lakehouse sort of represents an architectural shift for these types of applications, and so that's sort of what we're focused on at Ahana, right? So we're focused specifically on the SQL-based analytics There's other modalities, there's machine learning, graph analytics, and other engines that are also consuming the same data. We're focused specifically on the SQL aspect of it. And we chose Presto for the query part of that, which is because of its ability to scale and its openness. And the roadmap, right? There's a very strong price performance roadmap, and that we'll probably talk about in a second. And so that's sort of our focus at Ahana and why we chose Presto. Besides the query aspect of it, right? The data lake is evolving to include a bunch of data management capabilities. There's metadata, access control, governance, transactions, versioning, timetable queries, and other things that are expected of these sort of SQL-based business intelligence platforms. And so one big challenge that I see that we're working on at Ahana is sort of how to bring all these things together in a cohesive and consistent way that's expected of these applications, right? You got schema now living in the log, in the Delta log, and you've got, it's not in the metadata repository. There's even optimizer metadata down in these logs. It's not available in the metadata catalog that the optimizer typically uses, or there's privileges or access control information or column masking rules living in yet another service like Lake Formation or Apache Ranger. So there's an opportunity. We see a big opportunity. It's a little bit wild west from the data management side of it at this point, but we see a big opportunity to sort of help solve that particular problem. And so in a nutshell, we're a paring knife for SQL-based analytics in the Lakehouse environment. That's what our focus is, but there's more to it than just query. It's sort of bringing together all the data management features that are expected of these sort of SQL-based BI applications.
Sure. And you also hinted at something. You mentioned it, governance. It helps you solve that governance challenge from a pretty significant point of view, it seems to me, because when you have stuff all over the place, you don't have one marshaling area, if you will, which in this case would be Presto as the query engine. You're going to have a really hard time governing anything because it's all over the map. So when you can agree on a certain standard, when you can agree on this engine, I think that helps solve the governance problem. It also provides tons of data and analytics on what you're getting, how long it's taking to do certain queries, how long these reports take to deliver. So you get a better management of the costs, and that allows you to do some cost benefit analysis, right, Dave?
Yeah, I mean, there is multiple services at play here that, and Presto is sort of like the centralized where is the point where these things will be integrated, right? I think that's what you were getting at, right? So from that perspective, but it's a metadata catalog, transaction logs, access control services. So bringing that together, and then making it available through sort of the Presto lens is I think is probably the right way to think about it.
Yeah. Okay, good. And Tim, let me bring you back in. The data engineer is a very, very hot role these days. They are certainly in demand. You don't want your data engineers pulling their hair out, winding up like me. You want them happy. And so that is a consumption metaphor to keep in mind. Why do you think Presto is good from a data engineering perspective?
I think we could start by just, data engineers love the interactivity of Presto. So it's always on, it's always running hot, and, it sort of gives them that database-like experience over, things that, don't fit in traditional data warehouses. So that whole interactivity is extremely appealing. And so, within Meta, we try to make it so that, taking a step back, it's really, for many, use cases, it's the first tool that the data engineer will reach for is Presto. And it's the preferred tool. And so anytime you have to go out of that, that interface, there's, costs. So, there's, semantic differences between the query engines, like how the performance could be different. If something goes wrong, how do you troubleshoot that? And things of that nature. So like we've tried to work really hard to make it so that like they don't have to kind of like reach for another tool for the majority of these things. And so just because like we know that as soon as you do that, there's costs. It could be the cost in sort of the cognitive overhead for the data engineer, or it could be cost in the form of like let's say an alarm goes off and you have to stop what you're doing because some important data set sort of like doesn't fit in memory anymore. So that's like that. I think that's driven a lot of our work on batch and making it so that there is a more or less single unified batch story where our customers don't have to sort of like reach for many different tools. And then it's also sort of like motivated a lot of our work with the multi-layer caching and the performance work and the efficiency work, because we wanted to also work for very performance sensitive dashboards. And so bridging like these use cases from the large batch scale all the way down into the very low latency dashboards and high QPS use cases are something that like is very important to us, just so that just because data engineers' time is valuable, and we try to give them the best experience.
That's a really, really good point. I'll throw this over to Girish to comment on. I see you're shaking your head or nodding your head in the affirmative. Data time is valuable, and also not just time, but Tim mentioned a fun term there, cognitive overhead, which can be viewed, I think, as, what do I have to do here? How does this work again? That kind of thing. It takes time, and there's a bit of a mismatch between these different environments. So you want to create a very seamless experience for the user, save them time, save them effort, and really become a very useful tool, and one where it's like your go-to environment, right, Girish?
Yeah, that's absolutely right. I think having a go-to environment where you can do all of your data analytics, your data preparation work, all of that, all the things that you do as a data engineer is very valuable. So you don't have to switch between different languages, different tools, different environments. I think that becomes very taxing, right? Your productivity goes way down. See, the other thing I do want to call out about Presto and particularly the Open Lakehouse is I think we have a lot of customers and users of Presto who start small, right? They either work for a small startup or they work with a small set of data sets. And Presto is great because it gets you up and running right away. You can just download the code, get the cluster up and running in all of maybe a few minutes to an hour, and then you start getting your insights. But the important thing is that the same thing that you're running is also running at Meta and Uber scale, right? And so you can work with the confidence that as your needs grow, both in size, scale, and in complexity terms, the system is able to grow with you, right? It can handle whatever you're willing to throw at it. And it does it in an open way. And that's key, right? So maybe today Presto is enough for everything that you do, but maybe tomorrow you might need to use a different engine because you are at a scale where there's a different trade-off that needs to be made in architectural terms. Maybe you need batch processing, maybe you need disk build or shuffle or something like that, which Presto is not the best. Maybe Spark does some of these things better. Maybe there's another engine, right? But Presto can still be your interface through all the work that we are doing. And so your data engineer doesn't need to worry about it, but your system can evolve under the hood, right? So essentially you have this abstraction layer on top, which your data engineer works with, and then your system can evolve at the bottom. So in some senses, this is, you can think of it also as an API, right? Sort of like a application programmer interface in coding terms, but in data engineering terms, you can call it as an analytical programming interface, right? So you work with the same SQL, you work with the same sort of interfaces, but then the system evolves under you to handle all your growing needs. So,
yeah, and that reliability thread, I think, is pretty important. Maybe Dave will bring you in to comment on this. I think Girish and Tim are both making a good point here that if Presto is working at the scale of Uber and Meta, let's face it, these organizations have a lot more data than most companies out there. So if it works at that kind of scale, and that's where you want to prove it out, right? That's the proving ground. So we know that it works at scale. There are things that are going to be added over time, but I think that's a pretty encouraging line to hear. Dave, what do you think about that?
Well, what's even more encouraging, yeah, I mean, they've been running at, interactive queries over, multi-petabytes of data and multi-thousand node clusters, but there's some actually major improvements. I guess we've been talking about it probably in various places during the conference, but the new vectorized execution engine that's being written in C++ is something that we've been working closely with Meta and other companies on at Ahana, and I think that's going to be a real differentiator for what we're trying to do. The improve CPU throughput through vectorized execution, adaptive execution techniques. From an I/O perspective, there's a new cache manager being built in native code, and a cloud-optimized I/O subsystem that uses prefetching and parallel I/O to drive like cloud storage services like S3 to full bandwidth. The memory management, application-aware and adaptive memory management is being added. So all the GC storms and the inability, the inability to spill efficiently to disk will allow batch operations like hash joins, sorts, and aggregation and window functions to be able to scale vertically without sort of experiencing these GC-based issues that pop up. So, and we're seeing like in early benchmarks with like TPCH that the new engine can do on half the nodes what you need twice as many Java nodes to do the same work that you can do on half the native execution work. So we're super excited about that. That's going to make a huge difference in terms of price performance for our customers. Once we're able to bring that into our cluster. So we're heavily invested in that. And the other thing that I'll point out, which is stuff that we're actually focused on, is the native execution worker alone isn't going to really help you if you have a poor distributed query execution plan, right? So we're doing some work inside of Ahana there to help drive out the optimizer and distributed execution capabilities. We've hired Bill McKenna, who wrote the original Volcano optimizer back in the Goots Grapey days. He just joined us. So we're doing a lot of work. We're doing a lot of work to sort of drive out the optimizer roadmap and help improve that as well. So I think so it's great. Like Presto's great. Presto's been great. It's running at scale in Facebook, but we're super excited about the improvements that we're collaborating on right now.
Yeah, that's very cool stuff. And maybe Tim, I'll bring you back in to comment on this. Every time someone gets the bug of analytics and they start throwing queries at something and they get into it, and there's a speed that it needs to happen at in order for that thought process to continue. You talked about cognitive overhead, for example. There's also cognitive frustration, which is when that excitement gets truncated because something doesn't work fast enough or doesn't work at all. And that just changes the whole conversation. And this is really important because the human thought process at its ideal state is very fluid. And you're having this conversation with the data, with the environment, with the information. And if it's not stable, if it's not fluid, you're going to ruin that magic. So I think it's very important that you have these teams of people in large enterprises like Meta, like Uber, of course, Ahana, collaborating to collectively improve this thing, to improve the query engine, the optimizer, but the workflow, you mentioned multi-layer caching. There are lots of things that can be done to make those tracks as greased as possible. And I think the collaboration is key. But what do you think, Tim?
I think you're exactly right. And, we measure it, we try to measure all these things that kind of like affect, this cognitive overload. So if it fails, we measure that and we try to fix it as soon as we can, systematically. If there are, sort of like a resource, if there's some sort of resource unfairness, we measure that and we try to fix that. All the way down to kind of like, why the caching is so important. like we try to get the results back as quickly as possible, just because, like there is a flow, and as like the quicker that we get those results, the quicker that people can do their jobs and like iterate. And so like that's also kind of like what alluding to what Dave said as well. That's why we're so excited about like some of these upcoming enhancements that we're working on, especially related to vectorized execution, where we can really kind of move the needle on that and make things much more fast and efficient. So yeah.
Yeah, that's great. And Girish, I'll bring you back in, just speaking about one of my favorite topics, which is morale. When morale is high, good things happen. When morale is low, bad things happen. So what leads to bad morale? Well, friction points are the initial problem, let's call it. And if those can get resolved, either with sandpaper or grease or whatever, okay, you move past that. But when the friction points start adding up and don't go away, that really affects morale. And when people have to kind of go around the bend to solve some problem again and again, it's just very frustrating, and it ruins the psyche, quite frankly. And again, even though the machines are great and the data is awesome and all that stuff, it's the people at the end of the day who have to sort of ascertain what's really happening and come up with the ideas and test the ideas and figure out if it's going to work. And this is all a very, as I mentioned, fluid thing. So I think this collaboration is great because it's moving us all past one of these big hurdles, which is the frustration of waiting, of not getting what you want, and then the sort of cultural damage done as a result of that. But what do you think, Girish?
Yeah, I think that's a great insight. So I think that as engineers, right, as we write code and build systems, just imagine how it would be if you had to wait for a whole hour for your program to compile. Even worse, imagine how it would be if the way you found out there was a bug in your code was in production. If you go back 60 years, that's the world they lived in, right? Punch cards. So I think it's similar here, right? So I think before Presto came in, either you were using a custom system, a vendor provided system in most cases, or you were basically writing a Hive query and waiting for a few hours to see what happened. And Presto changed all of that, right? And I think that's why people love Presto, because it's fast, and you can basically get into this flow that you were talking about earlier, where the tool melts away, where you're directly working with the data, and essentially the tool is more of a medium rather than an impediment, right? It becomes transparent to you. And there's nothing like that to improve morale, right? At the end of the day, the lesser friction there is between your thought process and what you're working with, the better, right? This is why interfaces are important. This is why speed is important. And this is why reliability is important, because a big pillar of morale, of productivity is if every second query you run is an error, right? And you will not see that in Presto because we work very, very hard to make it work. Yeah, I think it's front and center for us.
Yeah, that makes a lot of sense. And maybe I'll throw for final comments. I'll throw it over to Dave, because you're working on this stuff. What's coming next? Where are we going, real quick?
Dave at ahana.io. If you are a black belt in databases or whatever, just come talk to me, and we'll sign you up to take this journey with us. It's everything we talked about. It's writing the new vectorized execution engine. It's working on the query optimizer. It's already pretty good, but I think there's a lot of things that we can do to bring up the state of the art there. And the other interesting thing that we have to figure out, if you want to come join us, is sort of like I mentioned, all these lakehouse integrations that we have to figure out to give these BI applications sort of the data management features that they expect. Not just the query. Presto's the query engine, but sort of, how do I integrate, Apache Ranger and Lake Formation that provides access control, row and column masking, Hoodie, Delta, Iceberg for consistent, snapshot reads, time travel, incremental queries, read-write transactions ultimately, So there's an opportunity here to try to figure out how to bring this together in a coherent and consistent view. So those are the three key areas. You know, well, there's sort of like price performance. There's sort of the data management features, and the other hard problem that we have to work on is sort of like, how do you make this available as a without DBA knobs, right? So solving the problem of, you know, like Snowflake, right? Snowflake, one of the big innovations there wasn't just sort of the architectural change that enabled elasticity, but there's no knobs, right? There's no create index statement. There's no, you know, there's not a bunch of tuning. You don't have a DBA in the loop. So I think there's a lot of challenges that we have to solve there. You know, if we're gonna enable even better query performance by adding support for secondary filters or secondary indexing, we have to solve the workload optimization problem, which means that something has to figure out which indexes to create, which ones to drop to accelerate the workload. So observability into what the application is doing, feeding that back into the system, back into the optimizer to do this stuff transparently, right? So that's where the bar is. And I think, you know, if there's anybody out there that really, you know, is interested in sort of working on those types of problems, feel free to shoot me an email.
David,
Ahana is very high as a company, so to tie the morale thing back in there, if you want to,
you can get things done. Yeah, get to the cold face. Well, gentlemen, thank you so much for your time, and thanks to Presto Con for bringing me into this equation. The last point I'll make is that transparency, open source, it really has changed the world of programming, not just at a code level, but at a cultural level. And I think that's very, very good for business. I think we're going to be plowing forward. That's why we're getting such advances, because now you don't have everyone reinventing wheels all the time. Sometimes you have to do that. But the open source community and that culture that comes along with it, I think is really yielding tremendous benefits. So thanks to all of you at PrestoCon. We'll talk to you next time.
Thank you.
All right.
Everyone.
Thanks, everyone. Appreciate it. Girish, Tim, I think Dave already dropped. Eric, appreciate it. Great discussion.